Hello, I'm Chen Liang. I'm presenting CustomizAR, a pipeline that facilitates interactive exploration and measurement of adaptive 3D designs. This work was done in collaboration with my advisors Anhong and Jeeeun. 3D designs have become increasingly accessible to the general public. As of 2021, there are more than 1.9 million designs that are publicly available online, which covers a wide variety of categories. Among all these designs, a specific type of design is called adaptive designs, which are designs that extend or enhance the functionality of real-world physical objects. These designs are popular not only because they are useful in daily life, but also because many of them are made with parametric modeling tools. So parametric modeling tools such as OpenSCADE can create models using code. Because key values are coded as parameters, others can easily adjust the value to generate a new design, which is specifically useful for adaptive designs, as now users can customize the model to fit a similar target object, but with different sizes. While customizing adaptive design seems to be easy to perform, users, especially novices, still face a number of challenges. The first challenge is to discover designs. On Thingiverse, for example, the user starts by putting some keywords such as bottle into the search bar. However, it may return irrelevant results or results of duplicated functionality. Also, it's challenging for users to see all possible adaptations, which is critical as some adaptations may not be realized by the user. The second challenge is to measure physical objects and adjust the design. Once the user selects a model, the user can open the Thingiverse Customizer, which is a tool that allows the user to see and adjust customizable variable of the model. And then the user can generate a new model directly. However, user still needs to interpret these parameters, determine which parameters are critical and need measurement, where to measure them on the physical object, and how to measure them. Even with the correct measurement value, user still needs to convert all these physical values into the digital space to get a correct customization. And measurement is also affected by tool availability and how the user performs the measurement, which has been shown to be challenging for novices. So it can be found that with the existing pipeline, there exists a gap between the physical and digital space, and the user has to take the responsibility of transferring information between them, including initiating the search, verifying results, interpreting parameters, and finally converting them back to the digital space. In this work, we propose CustomizAR, a pipeline that provides end-to-end support for users to print adaptive designs. The idea is to have the system bridge the gap by directly retrieving necessary information from the user's environment, collaboratively working with users on complex tasks such as measurement, and directly convert values back to the digital space. By doing so, the goal is to reduce the amount of required prior knowledge and human errors in this process. Based on the proposed pipeline, we created an interactive system which supports in situ object selection, design exploration, parameter measurement, and design export. The system starts by retrieving objects from the user's environment and initiate the search directly based on the user's selection. The system also supports an object-centric way of searching. After selecting the target object, the user can explore related designs by adaptation type, and then make a final decision on which design to customize. This search is supported by an object-centric graphical structure that we created by augmenting existing design metadata on Thingiverse. By mapping objects and concepts as nodes, the system can provide a more organized, object-centric way of searching, where the search process can be treated as traversing the adaptation graph. Then, the system can propose a list of parameters that need measurement. The user points the camera to the object as instructed by the system, and the system performs the measurement automatically. User can verify the results and adjust if needed. At the end, all values are automatically applied to the OpenSCADE code, and the customized STL file can be generated for printing. We then perform the technical evaluation and the user study to evaluate our system. The technical evaluation shows that the named entity recognition model we used for retrieving adaptation-related information can effectively detect adaptation type and target objects from design titles, while improvements can still be made on detecting such information in complex titles and titles with abbreviations and terminologies, such as Pi for Raspberry Pi and i3 for the 3D printer. We then got a diverse set of bottles and boxes and evaluate CustomizAR's performance on marrying them. We measured the diameter for 10 cylindrical objects and the length for 10 cuboid objects. As shown in this figure, the absolute measurement error is usually within 0.5 cm. The larger the object, the higher the measurement error. We then conducted a user study with 12 participants, where most are novices. We evaluated the measurement error in some real tasks and performed qualitative analysis on semi-structured interview and surveys. Participants were asked to first perform a design search task, where they need to find the design given by the researcher, and then a design discovery task, where it mimics a case where the user does not have a clear idea of what to print on. We use within subject design so that each participant use both the Thingiverse setting and the CustomizAR app. Through the user study, we found that participants use different methods for measuring parameters, which introduce a large variance on measured values. While the measurement error for boxes was relatively low, it was much higher for bottle diameters. It shows that in this case, using CustomizAR reduces the impact of human error and decreases measurement error. Participants also had different preferences between convenience and confidence. Participants prefer the CustomizAR due to its ease of use, speed, and it does not require additional tools. CustomizAR also helps the user with complex parameters. As P11 mentioned, for boxes it's easy, but for bottles, measuring edges is not easy. Like this could be curved, and I don't know where I should stop for this measurement. However, 5 participants still prefer manual measurement. As P5 mentioned that the measurement is more accurate if I measure it myself. I can actually see it, and I'm not sure if the technology is more accurate, even though they can be further adjusted. For design discovery, 7 participants prefer CustomizAR as it suggests more organized, clear, and relevant results. As P10 mentioned, on CustomizAR, everything is clearly labeled for its purpose, convenient and fast, but for Thingiverse, it's a little bit overwhelming. However, exploration freedom and control was another reason why some participants still prefer Thingiverse. As P6 mentioned, for discovery, the user is limited by what adaptation the app thinks is applicable to the type of object, and your creativity is limited by the detected object. Having control of the result was also important for some participants. As P8 mentioned, various filters can be used to fine-tune the search. Some users also suggest more diverse results, which, as P4 mentioned, gives a feeling of online shopping. This led us to the future direction of the project, where one direction is to further improve the design exploration experience, including suggesting loosely relevant results. Since CustomizAR uses a graph structure to organize design connections, it can also suggest designs with similar concepts or shapes, such as suggesting designs for cups as well when the user is searching for bottles, which could give more diverse idea on what to print. Having additional filters would also give users a sense of control and allows the user to fine-tune the result. Measurement could also be further improved, such as using higher resolution sensors, sensor fusion techniques to improve accuracy, or suggesting post-processing methods, such as using clamps or adding soft buffers on interacting surface, to give more flexibility on measurement error. With more advanced measurement methods, the system could also support more complex parameters. In conclusion, we presented CustomizAR, a pipeline for discovering and customizing adaptive 3D designs that are open source for use. CustomizAR provides end-to-end support for users to print adaptive designs. which can reduce the amount of required prior knowledge and human errors in the adaptation process. Thank you.